Okay, so today we are going to talk about building the Apple Lisa's operating system from the ground up, from source code that Apple released a couple of years ago. I'm going to assume most of you probably know what the Apple Lisa is, so I'm not going to go into any specifics about it. But back in January of 2023, Apple, with a lot of heavy lifting done by Al Caso and the Computer History Museum, decided to release the source code asterisk almost in its entirety for the Lisa operating system. It is not predominantly, it's entirely written in a variant of UCSD Pascal and 68,000 assembly. There's about 800,000 lines of stuff. Most of it's Pascal, some of it's comments, some of it's assembly, and that's spread around over more than 1,300 files. And if you cut the fluff out of that, you get about 20 megabytes in 1981 or 2-ish of Pascal and assembly, which is insane to think about. And up until relatively recently, you've not been able to compile it. And we're going to go into why. There was a first really big hurdle to clear, and that is there is not really any way to store that much stuff on a Lisa to actually do the work that we're going to be doing. So Apple basically made two storage options for the Lisa, and that was a 5 megabyte profile and a 10 megabyte profile hard drive. And the last time I checked, 20 is a larger number than 10. And you cannot span. There's no RAID on the Lisa, unfortunately. You are stuck with storing all of your project on one volume if you're working in the Lisa's development environment. So what alternatives do we have? Well, there's basically only one alternative. And it is almost certainly what Apple would have used back in the day, and that is a storage device called a data tower, manufactured by a company called Priam, or Priam. I still don't know how to pronounce that.
I always say Priam. I don't know.
We'll go with Priam then. So this is maybe the rarest of Lisa peripherals. There are some really hard to find ones. This is the hardest. There's only like 3 or 4 of these known to exist still. Alex managed to track one down. He started working out a deal to acquire one. And then that fell through, and we were kind of back to square one. We decided, hey, maybe we can reverse engineer it. Priam published the protocol information for how to interact with them. That was going to be a Herculean effort to reproduce, so we just said, we're going to shelve this, we'll figure something out and come back. And then there was a lot of nothing for a while.
Like a whole year.
Yeah, for like a whole year, we just sort of sat on this. So at one point, at the beginning of this year, I thought to myself, wait a minute, we have access to the source code. We can just go look at the storage drivers and see how everything snaps together. What if we can trick the OS into letting us have a profile that's larger? And a bit of foreword about that, I guess. There are a number of profile emulators, just like the Macintosh has SCSI emulators. There's some IDE and MFM emulators out there. There are profile emulators. And they work as you would expect. You define a virtual hard disk on an SD card that is a specific size, and the Lisa basically understands, oh, you have this many blocks, and a block is basically 512 bytes. Therefore, you have X amount of storage available. We're done. So the first thing that we found was on line 283 in the profile driver. There is this little section here that says if disk size is less than, we'll call it 10,000 blocks, or if it's more than 30,000 blocks, it's a 5 meg profile. And so where it refers to profile over there, that's the 5 meg profile. Where it says Seagate, that's the 10 meg. We don't care about the widget. That's irrelevant. So if you look at that first if statement, the thing you can kind of maybe intuit from that is, well, wait a minute. There's like a 15,000 block, or 20,000 block window in there. Why is it not just, oh, if it's X blocks, it's a 5, if it's X blocks, it's a 10, if it's a widget, whatever. Well, Alex decided, oh, well, what if I just make a virtual hard disk that's exactly 30,000 blocks? Well, it turns out you can make a 15 meg profile that way, but that's still less than 20. So in diving in to the driver, I kind of realized, wait a minute, that's an if statement with 2 16-bit integers, which is what UCSD Pascal uses. And it turns out these are actually long ints. They're not proper, just regular ints. So when that gets compiled, if statements aren't doing a lot of logic in assembly, those numbers are probably close to each other. And on the first install disk for LOS 3, there is one location on that disk where those numbers are close to each other. So I thought, okay, is it just as simple as us changing that hex 7530 to be 65535? And yes, it is. And with that, I had Alex patch that, create a 65,535 block virtual disk, and we had a 32 meg profile. So the Lisa can now actually store enough stuff for us to get started. So the next task was going to be getting files into Lisa Workshop. Now the Workshop is the development environment that was used for not just developing Lisa software, it was also the environment for developing the first generation of Macintosh apps, because if you're going to develop software for a computer that isn't yet on the market, you got to have something to do it on. All that was done on the Lisa at first. Ironically, for a computer that was designed to have only a GUI, it is text only. Except for, once again, ironically, the text editor, it is a graphical application. Yeah. At the time, we didn't have a good way to insert hundreds and hundreds of files into a disk image. I think we do actually sort of have a way to do that now.
Somebody created an application that can sort of do it now, but it doesn't work for anything other than the 5 meg profile, so still a little limited, but in the future, that'll be an option.
Yeah. So what we decided to do is, well, the Lisa actually accounts for something like this, and that is MacCom, which allows the Lisa to read Mac formatted floppies, just the Workshop. Just the Workshop. Yeah. So we thought, okay, well, let's just shove everything onto, 400K floppies, toss them in and start copying the files over. MacCom corrupts those files. So we can't use it. But there is another way. And that is serial file transfers. And the Workshop also has a way to do that. It's unreliable at any speed over 1200 baud. And this took Alex 60 hours.
And that's excluding having to type file names for each file.
Yeah, this is just the actual transfer process.
And there are 1,300 files, so that's a lot of individual files.
Yeah, and as you'll see, Lisa Workshop doesn't know what the heck a line feed is. So all those had to be corrected to carriage returns. There are also some special characters on the Lisa that don't make it over as well. That had
to manually recreate them on the Lisa.
Yeah, so this was tedious to say the least, but it worked.
It did.
So the main concerns going into this were both of us, and some of this really specifically applies to Alex, who's going to be delivering the brunt of the technical exposition here in a minute. We were both relatively new to the Workshop. Unfortunately, all of the stuff, I guess, in contemporary development, not really contemporary, I think Make existed in the early 80s. All the build scripts you would need to actually do everything that needs to be done were not included in the dump that Apple provided. We also don't really know what arguments needed to be passed into the compiler to get everything to work. And we might be missing files. We were missing files. I'm just going to throw that out there, because it turns out when you ask a company very nicely to turn over 40-plus-year-old source code, a lot of companies don't keep 40-year-old source code because they've moved on to bigger and better things. Square of Japan is a real good example of this. Go look into their problems. So decided to start with the easy stuff, which was just the apps, because they were fairly dependent on things that we already had access to in a ready-to-go form, like the system libraries.
Also, easy is relative.
Yeah, easy is relative. Sorry. Keep in mind, when Alex or I say easy, there's a lot of strings attached to that word. Then move on to the libraries, and then finally the chunk of the operating system itself, which, not easy. Starting out, just do everything that can be done on actual Lisa hardware, which means you're running at 5 megahertz, which is, you think about how slow it is to develop applications on an 8 megahertz Macintosh, you're dealing with something just over half as fast as that. Lisa M, which is sort of the de facto Lisa emulator, use that as little as possible. That's a break glass thing. I'll give you a preview. We had to break glass. And second, prioritize on getting the most amount of small things working as opposed to just fixating on the big things that break as we run into them. So the hardware that, again, Alex was doing a lot of the development work on this. I was working on some other stuff in my free time in the background that we'll come around to at the very end. developing all this on a Lisa 210 with a 2 megabyte RAM expansion, which is about the most amount of RAM you can have running that the workshop will recognize. Better build times, you can have more and more stuff open in editor. These are text files, obviously, so not incredibly demanding on resources, but we used Alex's ES Profile hard disk, Profile emulator to do all of this on. And instead of leaving a CRT on an already hard to obtain machine running for months at a time, all of this was just done through video capture to save on things. And now I'm going to turn it over to Alex for a little bit to talk about the application development.
Okay, so this is where we actually get into, building the code and hopefully getting some stuff working. And I decided to start with something really, really simple, just about the simplest application on the Lisa, and that is the calculator. Because it's just a single source file, and in the code it's called APHP for some reason. I don't know why it's called that, but maybe like HP makes calculators or something. I don't know. Maybe that's where it came from, but that's what it's called, and it's just a single source file, so nice and easy to build. Don't have to worry about linking a bunch of things together. It compiled very straightforwardly, as you can see in that picture. That's what the Lisa Pascal compiler looks like. And after it compiled, we just had to link it with all the system libraries, which we will talk about a lot more later. But those are these guys right here. Are you raising your hand like you? Yeah.
So you said you don't know what AP means. What does AP mean?
Oh, that means, we're not completely sure, but either Apple or application. Not sure, but that's just the file name. But all the apps will have an AP at the beginning, you'll see. But yeah, we linked APHP/HP with all the system libraries, which we will talk about a lot later, trust me. And after that, we have an executable that comes out the other end, and we just need to test it out. But there's a little bit more we have to do before we can actually test that executable. First off, we need to process a phrase file. This is where basically all the text strings that the application uses are stored. It's a separate file. It's just nothing but text strings. And we have to run that through this alert generator that takes that and puts it into a format that the desktop manager can understand. And so we just run it through a program called alert, and it spits out an alert file on the other end that is the processed version of this text file. And now we actually have to figure out how to install the application into the operating system. We can't just put it on the disk somewhere, because files that show up in the workshop don't actually show up in the graphical Lisa OS by default. You have to make them show up in the graphical OS. And we do that using something called install tool, which will actually make catalog entries on the desktop for these applications. And you have to give them very specific names too. You have to call them T some number obj for the object code file of the app itself, and then T some number, it's got to be the same number of course, phrase for the phrase file. And the T stands for tool. So each tool, each application has its own specific number. You can't have two apps with the same number, of course. And so I just chose 100 for the calculator, and we ran install tool, and that's what it looks like. You just answer a few questions, and it will make that catalog entry, and look at that. That is the original calculator right there, and that is the new calculator, which I very creatively named new calculator, on the right. And it worked perfectly. So that was our first major success. This gave me the confidence I needed to proceed. I thought maybe this would, another question?
Yeah, so is there a limited number that you can put in, or no? Like you can put in any number?
For the tool number?
Yeah.
I'm not, I think any 32-bit integer would probably work. I haven't actually tested that, but any 32-bit integer, so it can go like really. I'm pretty sure. I haven't actually looked into that, but you can go pretty. I know you can go over 65,535, so it's bigger than 16-bit for sure.
You only have 2.7 billion.
Yeah. It could be bigger. It could just be any like text string that consists of numbers. I'm not sure. I'll have to look at that. But once we did that, we also did the calculator, we also did the clock, but I'm glossing over that because it was also very simple, and this presentation's already 171 slides, so we're having to move pretty quick with some things. But then we moved into actual Lisa OS apps, the like main 7 apps that make up the Lisa application suite. And the first of those was Lisa Project because it's the simplest of them. So start simple, right? And it's called APLP. You can probably figure out what the LP stands for. And it consists of a whole lot more source files than the calculator or the clock. It was like 20 source files, I believe. And a lot of the source files also rely on other source files using what are known as uses statements in Pascal. And the challenging thing here is that you have to build, if a certain file uses other source files, those other files have to be built before you can build the file that uses all of them. And there are a lot of very complicated relationships between certain files using others, especially when you've got 20 of them all together. You can see some examples of those uses statements right there. And so how do you figure out what order to compile them all in? Well, you make a spreadsheet. And this is actually the spreadsheet for Lisa List, because I couldn't find the one for Lisa Project, but it's the exact same idea. Put all the files down, spend a bunch of time going through the source code, and come up with an order right here. And if you notice, there are a lot of items here that don't actually have numbers next to them. That's because they are actually included by other source files. So you can think of like all of the LM-mat entries here, for instance, as just one big file, basically, because those other ones are all included. So that's why some don't have numbers. But another issue we're encountering here, now that we're getting into really complicated stuff, is that manually running the Pascal compiler for each file like this would take forever by hand and would not be practical if we had to do it multiple times. So we need to start writing some build scripts to actually automate this stuff. And luckily, the Lisa has a scripting language called exec that you can use to actually write some pretty cool, relatively complicated build scripts. And so that's what these are right here. This is the script for assembling Lisa Project because it has 2 assembly source files. And then over here, this is the script for compiling all of the Pascal source files. And there's another script for linking them as well. But these, we had to write all of the build scripts ourselves. So that was a lot of work. And just assume that everything from here on out, we wrote scripts for, because they get pretty complicated from here on out. So we wrote the scripts. Then we had to link everything. This time we have to link all of the files that we compiled with the system libraries. And once we did that, we have to generate the alert file, run install tool, and generate an icon. I left out the icon thing before, but I drew my own icons for all of these. So you'll get to see some lovely artwork for some of them. And this is what we get. There's Lisa Project, and there's my really ugly icon that kind of matches the original, but not great. But it worked on the very first try. So pretty awesome once again, another big success. Then we move on to Lisa List and Lisa Terminal. Basically identical process, nothing to say here. They went very smoothly, and you can see lovely icon. Lisa List looks terrible. Lisa Terminal actually looks kind of okay. But yeah, they went great. Then we had Lisa Write, the word processor. And this is where we had our first major roadblock. So, well, Lisa Write, it was actually pretty cool because it had a spell checker built in, but it's copyrighted by HM, Houghton Mifflin, Houghton Mifflin. I don't know how you say that, but that company, I'll call them HM from here on out. The dictionary itself wasn't included in the source release because, of course, it's still copyrighted. We didn't expect that to be included. But for some reason, they also left out some of the supporting code that helps the spell checker work. And, well, you wouldn't think that would be a problem, but it actually kind of is because, well, those files are used by other source files. And so if they're excluded, things won't compile properly. So what do we do? Well, there are 2 different options. We could either recreate all of the routines that exist in those missing files, just make dummy routines that just immediately return and don't do anything. Or we could go through all of our existing source code and remove all the references to those missing routines so that they just never get called to begin with. And, well, then it'll compile just fine because we're never referencing anything that's missing, right? So that's what we do. I chose that second option. And the first thing we do to do that is we just remove all the uses statements that use the missing files. Then we compile things and we wait for it to list out a bunch of errors for missing functions and procedures that we don't have. Like here, we're missing set heap zone spell. That's part of the spell checker, of course. So we see that error, then we just go over here to the source file where it exists, and we just comment that line out and rinse and repeat 50 times until all the errors are gone. And
remember, this is being done in real time on a 5 megahertz machine. This isn't like using GCC to compile Hello World.
It takes forever. And after all that was done, look at that. Lisa Write. It works, but not quite. There's a catch. I was going to play a video here, but for the sake of time, I'm not going to play the video. I'll just tell you what happens. When you try and type something, the character shows up, but then the whole computer locks up. You can't do anything. You can't close the application. You can do literally nothing. So we got problems. But following rule number 2, focus on getting most things working over prioritizing one thing. I thought this was pretty clever. We're going to set aside all our problems with Lisa Wright for now, and we will come back to those a little bit later, or actually a lot later at the very end. So we're going to move on. We're going to move on to Lisa Draw. And it's a very complicated app, a lot of source files, but really easy, no problems at all. And I'm kind of proud of the icon for that one. It looks pretty good, pretty close to the original. Now on to Lisa Calc. This is a spreadsheet, and it was pretty complicated actually. So it does things a little differently than the other apps in that instead of just putting all the application code into the application itself, it puts most of the back-end code into a library called LC or BGlib. And then the front-end code goes into the app itself. And you're probably wondering why it does this. We'll talk about that in one moment. But what this means is that we need to build LC or BGlib before we build Lisa Calc itself so that we can then link Lisa Calc with LC or BGlib. And well, the LC or BGlib code ended up being in the Lisa Calc directory. So it took a second to figure out what code goes with LC or BGlib and what code actually goes with Lisa Calc itself, because there's no guidance on any of this. But eventually, once I figured it out, I was able to start building LC or BGlib, and compiling all the files was fine, but how do we link it? That's the challenge, because it's not executable. It's an intrinsic library, which we will talk about a lot later. But that means that a regular link for linking an executable program isn't going to work. We need to do an intrinsic library link. But the Lisa Workshop User's Manual says that the current implementation doesn't let you create intrinsic units. They can only be created by Apple. So what do? Well, we try some stuff. And guess what? Apple just completely lied. If you give the linker the +I option,
Apple lied?
It just works. It just works. I don't know. Its output is a usable IU library file. I don't know. Very, very weird. But it works. It works. Yeah, they definitely would never lie about anything. And there's one more thing we have to do, though. We have to install LC or BGlib into the system's intrinsic library directory file. We'll talk about it a lot more later. Just trust me for now. We run something called IU Manager, and we tell it overwrite the existing entry for LC or BGlib with our new one. And it doesn't. And then, now that we've done that, compiling and linking Lisa Calc itself is really easy, and it works. And the icon looks really good for this one. It actually looks very close to the original. I'm proud of that one. And then finally, Lisa Graph. This is our last of the 7.7 apps, and it's called APBG. The BG stands for Business Graphics, which is the original name of Lisa Graph. And well, this is where LC or BGlib comes in, because well, nowadays a spreadsheet and a graph making program, they're the same. They're together, right? Like Excel. And well, that means a lot of the code is shared between the two, cells in your spreadsheet. It's the same between the two programs. So that's why we have that shared library, LC or BGlib. It's a library that contains a lot of the back-end code that's used by both Lisa Calc and Business Graphics. So having that library allows us to just have a really small front end for a Lisa Graph, and then we can just link that with the existing LC or BGlib, and it makes both applications smaller. So that's why we had that library file. And this makes it really easy because Lisa Graph is really tiny, easy to compile and link. And once we do that, there's Lisa Graph. And there's our best icon yet. That looks so close to the original. Really good. So that's all the 7.7 apps. We still have the preferences window, though. And one more app that's not really an app. But this is called APPW, and it seems straightforward at first, but there were actually a couple compiler errors. And I was scared at first, but it turns out it wasn't a problem. So the errors came from procedures that were being called, and the procedures were parts of certain Lisa libraries. But the procedures just didn't exist in the libraries that they were referencing. So I was like, what the heck? But I looked into it a little bit further, and I discovered that the preferences window, it contained 3 different versions of the preferences tool. You can see them here. One of them is the latest and greatest, the one that we were actually trying to build. And then there were 2 others, though, that I didn't even realize were there. One is like an older version of the UI tool, and then one is command line based, like super old. And so it turns out that they were just written for older versions of those system libraries. And so that's why they weren't working, because the older versions of the libraries had those calls that the new ones don't have. So that was easy. We could just ignore these 2 old ones that probably wouldn't work anyway and just build the new one that did compile okay. So we do that, and bam. Not proud of that icon, but at least you can tell what it is. And also, read this comment real quick. I found this in the main preferences program. What the?
If anyone understands what this is referencing, either now or if you're watching this online later, please let us know.
Yeah, the only reference I could find to it online was someone else posting the comment from the source code release going, what the heck is this? But yeah, I found that, so that's interesting.
This is some Hunter S. Thompson level of comments, so.
California, the 80s.
Yes.
So next up, we got the desktop manager. This is APDM. This is the last thing in like the applications folder. This is huge. Most of the source files are like between 5,000 and 7,000 lines each. They are massive. And this is basically the graphical shell of the Lisa. And I knew this was like part of the shell, but I wasn't sure how much of the shell came from like the OS and the system libraries versus this. I just wasn't sure about that, but we're about to find out. So I compiled and linked it. That was all very straightforward. And the question is, how do we install it though? Because well, we can't install it to the desktop with install tool because it is the desktop. So what do we do? Well, there's a tool. I actually glossed over this. We deleted some slides, so we don't have context for this really, but there's something called the environments window that lets you select whether you want to boot into the workshop or the office system. And we know that the environments window is what lets you select the office system, right? So we just need to figure out what the environments window is launching to launch the office system. We just need to name our executable that. And it turns out that's just shell.whatever. And the whatever is what will show up as the name of the operating system environment in the environments window. So I named mine shell.alexthecat123 since that's my username online. I like cats. And when we choose it, bam, we get to the desktop. So we successfully compiled what everybody thinks of as the office system, the desktop itself. So that was pretty dang cool. So this is the entire graphical shell too, which is really, really neat. Like the entire thing is contained in this one application. And since it's just a single executable, you can actually launch it from within the workshop shell, which is really cursed because it's like running a shell from within a shell. And it actually works, but then when you quit out of it, the workshop editor gets like really screwed up and weird. So it's definitely not like perfect, but you can do it, which is kind of funny. And also there are these two compilation flags inside of the desktop manager that are both really cool. One of them, this network flag here, kind of gives you a look into what LOS could have been in the future if they developed it a little bit more. If we set that to true, this icon pops up on the desktop. It looks like a little filing cabinet. And that was eventually going to be like an inbox or an outbox for sending and receiving mail. But it doesn't really do anything here. They were very early into the network release. You also can't run this because it corrupts the file system and it like duplicates the clock onto the desktop each time you reboot. So yeah, you can't really do anything with it, but it's cool to see. And then the other flag, I was going to talk about that, but we're going to gloss over that too because we're out of time. But there is one other app in here, APIN, the installer, but we'll get to that later on. And we're going to move on to the libraries of Lisa now. And now we get to talk about those intrinsic libraries that we were referring to earlier. So programs can use either regular or intrinsic libraries, and this is basically statically versus dynamically linked libraries. So regular libraries are created by the programmer, and you statically link them with your application at compile time. And so what this means is that the library itself gets copied into your program executable at linking time. So your program is going to grow in size by however big each library is when you link it. Whereas intrinsic libraries, they were just created by Apple up until now. Now we can create them too. And they are dynamically linked at runtime, which means that you only need one copy of the library on the entire system. And when you link your program with it, the library does not get copied into your program. Your program can just reference that single copy on the system at runtime. So it saves program size at the slight expense of a little bit of speed, but whatever. Yeah, and that too. But yes, the Lisa does need as much speed as it can get, but disk space was also pretty limited, so it's an understandable trade-off. And all the intrinsic libraries stored on the system, they're all entered into a directory file called intrinsic.lib that tells the OS where each library can be found and which ones are present to begin with and what is contained inside each one. And so we basically just need to generate all these. These are all the ones that are provided with the OS. I'm not going to talk about all these, just read what they are. Don't have time to go into each one, but we will talk about building them here in a second. We have to build all of them now. And the libraries folder in the source release, it has a lot more than just those, like, when you consolidate them down, basically just 9 libraries there. So how do we figure out what code needs to be packed together, linked together to form each of those libraries? Well, we can look in IU Manager and we can actually see what is contained inside of each of the big system library files to find out what individual libraries from the library directories in the source release go into each of the big library files. And it's a challenge, but you can do it with enough determination. And boy, did this project take 5 months and a whole lot of determination. These are all of the library directories in the source folder. So these are all the ones that we had to figure out how to consolidate into those 9 or so system libraries. And once again, I'm not going to talk about what all these mean, but you can read. So read these real quick if you want to know. Whoops. And now we just have to go ahead and build them. And my strategy here was, before we actually link everything together to form those intrinsic libraries, let's just compile all of the library files first to get any potential pain points there out of the way first. And then we will go back and link everything together. I did these in a very weird order, but let's ignore that. That was just because I had some weird thoughts at the time that were incorrect. So we'll ignore that. Some of the libraries also had little cool Easter eggs and things in them that we'll talk about along the way. And yeah, let's get into it. So first up, we have libos. This is basically just syscalls, that's all it is. And very easy, but it also had 2 little cool programs hiding in it. It had bless, which is bless as a volume, and also copy master, which will copy an entire disk, block for block copy from one disk to another, which was kind of cool. And it makes it bootable. So neat little programs there. Then libpl, this is the Pascal runtime library. Very important because all the OS code basically is in Pascal. But we're missing some files. We are missing 4 files. And well, what do we do? Because these are very important files. Well, I searched the entire OS release, all the source code, for references to these files. And luckily, I actually found them. They were hiding in a different directory. They were hiding in the OS directory, where the actual OS source code is. And I was able to extract them. Also, look, some of these are from 1981. These are like ancient, very early in the Lisa's development. But I was able to extract them, get the parts we needed, and move them to the Pascal library directory. And everything compiled, so this means we shouldn't have any problems later on when we try and link it into the Pascal library. Definitely no problems. But now onto the hardware library. All assembly, very low-level stuff like hardware interface routines. You can see an example there for showing and hiding the cursor. Very simple stuff. And it all compiled and assembled very straightforwardly. But the interesting thing here is that it doesn't actually form an intrinsic library. It actually forms a driver file instead. It's called system.lld, which it stands for system.low-level drivers, and it's loaded by the OS like very, very early in the boot process. And well, luckily, this is one of the few times where we actually have instructions for how to link something. This file is included in the source release. It tells you how to link it. And well, it was kind of important to know that too, because we have to use a special linker option called +P, which does a physical link instead of a logical link. And the reason we have to do that is because this is loaded so early in the boot process that the MMU hasn't even been initialized yet, because the MMU initialization routines are actually in this code. So it can't be loaded into logical address space because the MMU is not doing anything yet. So that's why we have to do a physical link here. But this all went very smoothly, although there is something else here that's really cool. There were some demo programs. There's libhardware/stunts, which is just really cool hardware demos. There's Pepsi tests, which is more hardware demos, but for the Pepsi system, which is the code name for the Lisa 210 instead of the 2.5. And there's keyboard, which is pretty boring, but it basically just shows you what keyboard layout you have and lets you change it. These have a theremin that you can actually control with the mouse. You can move it left and right for pitch and up and down for volume. I was going to do a demo, but we don't have time. Come by our table with the Lisas if you want a demo. We will be happy to show you anything you'd like to see. What?
Oh, the other building.
Oh, yeah, main building, the
in
table with
Gundy.
the 4 Lisas on it. You can't miss it. Next up, libfp, the floating point library. Pretty much all assembly and a lot of files too, although a lot of the files were for an older version of the library that seems to have kind of just been mushed in there. So, a lot of them weren't necessary. And it almost built perfectly on the first try, except we're missing a file again, libfp/stir-to-dec. So we just need to look through the code base to find this file. And unfortunately, this time, it doesn't exist anywhere. So, well, we're going to set this one aside again following rule number 2. And we'll come back to it a little later on. So next up, we have the storage manager, the parameter RAM library, and the internationalization library. All really boring. The parameter RAM one included a document just telling you how parameter RAM is organized, which is kind of cool, but not much else to say. Pretty straightforward. Then QuickDraw. Well, first off, rest in peace, Bill Atkinson. If you're not aware, Bill Atkinson, the creator of QuickDraw, passed away a couple weeks ago. So rest in peace to him. He created some pretty impressive stuff here. Very optimized code, all written in assembly. And it all assembled great. And there's this cool little demo here. If you've ever done anything on the Lisa in the workshop, you've probably seen this demo actually. But it all worked great. And if you're familiar with the MacPaint source code release from a few years back, where they released the QuickDraw source code, this QuickDraw source looks basically identical to that. So it appears as if the Mac and Lisa versions are identical, just there were some compiler flags that were changed between the two to build it either for the Mac or the Lisa. So that's kind of interesting.
I have a question. How much of the Lisa source code was repurposed in building the Mac OS? Do you know?
We don't know for sure, but most of the Mac source code was written in assembly and not Pascal. Yeah. So like the ideas from the Lisa were repurposed, but like very little of the actual code from as far as we're aware was repurposed. QuickDraw certainly was, but aside from that, probably not a whole lot like directly copied over. Database library, easy, nothing happened. Font manager, this one was straightforward, but it also came with some interesting programs. libmaster, which will take individual fonts that you've designed and will mush them all together to form the system font file. Pretty cool. I've never made any fonts though, so can't attest to whether it works or not. And then make Hure, which makes a font heuristic file, which is also needed by the system. Not really sure what it does. I haven't reverse engineered any of that yet, but I'd like to. That one doesn't work though, so I'll have to look into that a little bit more to see how to fix that. Hopefully someone will figure out how to make new fonts too, because that would be pretty cool. The next up we have the window manager. It also built really easily, but there's some hidden things in it as well. Some of these we were aware of before. I'm not sure if we were aware of all of them though. There's Shift Option 0. This shortcut will immediately dim the screen to black. So if you're doing anything you don't want people to know about on your Lisa, you can immediately dim the screen. Then Shift Option 4 will print the screen. This one's really cool. You can just print it straight to the printer. If you want a demo of this, come on by and I'll show you. It's really cool. And then Shift Option 7 will actually take a screenshot and save it to a floppy disk as a raw bitmap. So that's kind of cool too. Those keys are on the numpad. Regular ones won't work, by the way. The Lisa also has a monkey in the window manager. So if you're familiar with the monkey from the Macintosh, the program that they use for basically testing the OS and the applications, where it would basically just send random keyboard and mouse events to the computer and try and crash it. The Lisa has a monkey as well. And it's only enabled if debugging is enabled, but it actually works, and it is so cool and mesmerizing to just watch the monkey just like click random things on the screen and draw pictures and Lisa draw, and it's so cool. If you want a demo of that, come by too, and I'll be happy to show you.
Well, and that was sort of the acid test in the end for you for whether or not it would crash the end result of all of this as well.
The Lisa ran for 7 hours when I tested with the monkey without crashing, so that's some pretty good reliability. So now we have the scroll bar library and the alert manager, which shows like alert pop-ups on the screen. They both were very smooth. The alert manager has a program called AlertGen, which this is that same program that would process the phrase file and generate an alert file. So we have the source code to it as well, which is pretty cool. Then finally, we've got the printer. Of course, printers have to be complicated and painful. That's just how they are. So we got the printer library. Not going to go over all this, but basically, it compiles and links into like a ton of files here. It is super convoluted. The only one I'm going to mention is this one because it's going to come up again later. This is just the background print process that handles printing. It like handles print jobs, it prints in the background, that sort of thing. Tons of other stuff too. But I had to figure out which files get compiled and linked to form each of these files and how to do it. Very, very convoluted. But luckily, there were some partial build scripts in the libpr folder. So I had a little bit of help with this one, which was insanely lucky, but it was still quite difficult. There was a printer demo in there too that would like print some like cool little shapes and I don't know, just cool stuff on a piece of paper. And I wanted to build that as well, but it was another program that seemed to be written for like outdated versions of the library, so I couldn't get that to work either. But with some extra effort, probably could. And once again, we'll link the actual main printer library a little later on though. That was just all the extraneous nonsense in addition to the main printer library file. Then all the scrap, which is basically the clipboard library, universal text, filer.com, basically talking to the file manager, field editor, so editing text fields, table editor, pretty obvious, the toolkit, which is the API for developing Lisa applications, and quick port, which is for quickly porting applications from the workshop to the graphical office system. All those were really easy, although the toolkit and quick port were both really big and took forever, but all quite straightforward. Once again, easy is relative, but they were all quite easy compared to some of the other stuff. So now we have to actually link these into the intrinsic library files themselves. This is scary because if we fail, the system's not going to boot anymore because it relies on these intrinsic library files in order to run. So we got to be very careful and make a lot of backups. So first we do iOS paslib, and this is the Pascal runtime library. So it's very important to the entire system, and it links just fine. But when we try to install it into the library directory with IU Manager, it didn't work. It got unhappy because there was apparently some stuff missing from it. And well, what I did is I used this tool called dump obj that's on the Lisa that dumped both the original object code for the original iOS paslib and the new stuff for my new iOS paslib. And you can see here that there's actually some discrepancies. The original iOS paslib had some extra procedures in it that my new one did not have. And it's these three in particular. And none of them, I couldn't find any of them in the source code, so we're just kind of screwed. I could probably rewrite power of 2 because it just returns powers of 2. That's not too hard to rewrite. But these two, I didn't even know what they did. So we have a bit of a problem there. But I found a solution. It's not the most optimal thing, but it works. I disassembled the original iOS paslib and then tried to find the locations of those procedures in that disassembly. And then I just copied the code from the disassembly, made a new source file, and threw that code in there, and then relinked a new copy of iOS paslib with that code replacing the original code for those procedures, and bam, try that out. So basically, we disassemble using dump obj, and it gives us this disassembly here. I was hoping that the procedures would be labeled in the jump table, but for some reason they weren't. Other procedures were, but the three we needed were not. So bad luck there. But I used the fact that we have the code for the mol4 procedure, and power of 2 is listed right above it in the listing of procedures here. So I figured I'm just going to search for the code for mol4 and then assume that power of 2 is probably going to be the procedure that's right above it in the disassembly. And luckily, I ended up being right. So that's mol4. That's power of 2. So I looked over it, confirmed it looked like something that seemed fairly reasonable. I did the same thing for memav and heapre, those other two procedures. I extracted that, put that into some fresh new source files just like that, and formatted them the way the Lisa expects. Then we rebuild and try install into intrinsic.lib, and it works. And I rebooted the system, and the system booted just fine. So iOS paslib is a success. Then we do iOS fplib. Remember, we were missing that file for the floating point library. So what do we do here? Well, we do the exact same thing. We disassemble the floating point library, steal the code for that particular procedure out of it, and then recompile everything with that little bit of code. And it worked for fplib as well. So those two problem areas for the libraries are no longer problems. Then printer library, quick port library, the two toolkit libraries, and then sys1 and sys2 lib, which are basically just giant system libraries with tons of random stuff just thrown into them. They all worked really well, really easily, and these took a while, especially sys1. It took like 5 minutes just to link because it's tons of code in there. But they all were very uneventful, and it just worked. So that was really nice. There are two libraries left, though, that I haven't talked about, objiolib and sulib, which basically handle parsing code from an object code file. The problem for these is we don't have any of the source for either of them, which kind of sucks. So there's not really a whole lot we can do here. I just kind of said, whatever. It's not like this is something people would care about modifying anyway. Nobody's ever going to care about changing the structure of an object code file, so we're not going to need to really modify these. So whatever, we succeeded with everything people would care about changing. Let's just leave these alone. So with that out of the way, all the libraries are done. The operating system. This definitely isn't going to be challenging at all. So 122 source files make up the OS itself. And that all ends up compiling down to about 15 files in the end. So 10 of them are system.cd underscore something. And these are, the CD stands for configurable driver. So these are basically driver files for all the Lisa's peripherals. So one of them, for instance, is system.cd profile. This is the driver for the profile hard drive. Then we've got these 4 files, system.bt underscore something. These are the bootloaders for the Sony floppy, the preamp data tower, the profile, and the Twiggy. There's actually one included for the Twiggy, even though LOS 3.0 doesn't support the Twiggy, interestingly enough, but it's there. And then finally, system.os. This is the operating system itself. Very big, very complicated. So let's talk about the bootloaders first, the system.bt files. And they all have 7 files in common. We don't really care about most of these, but this is the main loader that actually loads the operating system. We'll be coming back to that. And then this is cool. If you're familiar with the Lisa's DRM scheme, this is the assembly source file that actually reads the serial number to check the DRM. So that's kind of interesting. But yeah, each bootloader consists of these 7 common files plus like 1 or 2 device-specific files, depending on whether it's the Sony, the data tower, the profile, or the Twiggy. And so that's not too hard to build. We just compile and link everything. But the issue here is we can't just put the bootloader file on the disk in that location where the original file was sitting. That's not going to replace the bootloader on the actual hard drive because the bootloader is sitting in the boot blocks. That file is just a file on the disk. And the reason it's there is so that when you format a new disk using the Office system, it will copy that file from that location on the disk into the boot blocks of the disk that you're formatting. So the only way that we can actually test the new bootloader is to format a new disk and have it copy the bootloader from our new file into the boot blocks of that disk. So what this means is that we have to reinstall the entire Office system in order to test this. We have to format a new disk and install the entire Office system onto that disk to make sure the bootloader gets copied over there and make sure that it boots. So this was pretty painful, but it worked, and I'm going to assume that Sony preamp and Twig worked too, given that profile worked. So if anyone wants to test that for me, feel free to, but I'm going to assume they work. See, ta-da, it works. Then we got the configurable drivers, the CDs. There are a lot of them, but the only one we're going to really care about here, we're going to build all of them, of course, but the one we're going to talk about is profile. Because, well, guess what? We're out of hard drive space again. We have 77K free on our 32 meg disk because even though the source code doesn't take up that amount, well, once you got object code files all over the place, it balloons up to a pretty good size. So we need a bigger disk. We need a bigger disk. Each configurable driver, it consists of these 3 common files, and it also consists of 1 or 2 device-specific files. And we're going to need to change one of those device-specific files for the profile. That is going to be system, I think it's source/profile it's called. Sorry, I forgot what it was called for a second. This is that same file Will talked about at the beginning with the 9728 and the 30,000. And when we patched it earlier, since we were just patching the binary, that was only a 16-bit field. So the biggest number we could put in there was FFFF to maximize our hard disk capacity to 32 megs. But now that we have access to the source, it's a long int in the source. So we could make it a 32-bit value, largest 32-bit value that you could possibly make it if we wanted to, right? And so I just put something random in there, 500,000, to make the disk a maximum size of 500,000 blocks, and recompiled it. And it compiled and linked, and I made a new volume that was 50 megabytes in size, and guess what? It recognized it. And now look how many free blocks we have. Plenty to finish this project. So another success. Yay. Now we're going to start the actual OS itself, but a little worried about this. On the Lisa FAQ website, there are these 2 error codes. One's for system.unpack is missing, and another for unpack of system.os with system.unpack failed. But what on earth is this unpack nonsense? Because, well, we haven't dealt with any like code packing or anything so far. So how are we going to pack the OS? Well, it turns out there's this program called PackSeg that does it for you. It packs, basically compresses code files, and then there's like a pack table that it generates called system.unpack that tells the system how to unpack the file. I haven't looked into the format of any of this, so don't ask me how it works. I'd like to figure that out later, but I haven't really looked into it much. And I was able to find some copies of PackSeg on some like ancient Twiggy images on BitSavers, but they don't work. I think they use older versions of the libraries too, so they don't work on the workshop. So we don't have PackSeg. So I was a little worried. Are we going to have to write our own version of PackSeg? Because it's likely the bootloader only can load a packed operating system. But no, it turns out the bootloader is really smart. That loader file it checks whether the code in system.os is packed or unpacked. And it will automatically load regular old unpacked code or packed code, depending on what it finds. So it's actually a pretty smart loader. There was no reason for them to do that, but they did. So thank you, Apple, for writing it that way. So we can continue without packseg, thank God. And well, we make another spreadsheet. This one's huge. We got like, God, I don't even remember how many files, but tons of files to build, and they all have numbers beside them this time. Lovely. And compiling and linking everything went fine, but there is a discrepancy. We haven't talked about segments yet, but we'll talk about them here in a second. These are all of the code segments that got generated when we linked our OS. But luckily, Apple actually included a file with the source release that shows the segments that came with the original OS. And you'll notice we got some size discrepancies. Like for instance, the blank segment up here in our OS is about 10K. In the original OS, it's about 8.5K. That's a 2K difference. What the heck's going on there? Well, it definitely won't be a problem. We'll ignore that for now. So we replace the original system.os with ours, and we try and boot. And we get a 10730 error. What does that mean? It means system.os is corrupt. So clearly something isn't quite right here. And after looking into it a little bit, the 10730 error, it comes from the loader. It comes from the bootloader. So we haven't even started running the OS yet. It's still loading OS code. We haven't even jumped to the OS code yet. So maybe the file format's bad. I don't know. Let's look into loader and see what can cause this error. Well, it turns out there are 4 different things that could cause it. And you can look into the file and confirm these, but just trust me. One, it could be an OS file that doesn't actually have code in it. So no code header. It could have like data headers, but no code header. 2, an OS file that has more than 32 segments in it. You're not allowed to have more than 32 segments on the Lisa. Number 3, a code segment that has a length of 0. Obviously, that doesn't make any sense, so error. Or number 4, a segment that fails to properly load into RAM and be mapped into RAM by the MMU for whatever reason. These first 3, they don't all make a whole lot of sense because like our file, it linked okay. We know we don't have more than 32 segments. It wouldn't make sense for one to be empty because they all have sizes. That doesn't make any sense. So it's probably number 4. Something's failing to get loaded into RAM. But we need to be able to print some debug info to figure that out. The issue though is we're still in the bootloader. We don't have access to Pascal's write line. We can't print anything to the console yet. And we don't have access to the debugger, Lisa bug, either. So what do? We really need to be able to look at the Lisa's RAM to see like what's being loaded into RAM and what's not. So, well, we got to go to Lisa M because there's not an easy way to do that on the actual Lisa. So unfortunately, we got to switch to an emulator at this point, which kind of sucks, but not really another way to move forward.
You want to switch off for a second?
Yeah, if you want to talk about,
Yeah.
Will wrote this procedure, so Will's going to cover this slide, and then I'll take back on the next slide.
So this is something I'm both oddly proud of and shameful of at the same time because it's going to do something you're really probably not supposed to do as a programmer. So we don't have access to anything like in the Pascal library to let us barf up info on the screen. So my first thought, because at this point in the process, I had been teaching myself the finer points of Pascal for a while for, again, something I'll talk about later. So I thought, we were on a call together and we had a bunch of these over the last several months. And I thought, well, wait a minute. We don't have access to write stuff onto the screen. Well, what if we just wrote ASCII into RAM? I mean, Pascal's a mature language. It knows what a pointer is. You can write stuff directly into memory. And so I couldn't call it write line, so I just decided to call it write jank because this was maybe the jankiest bit of Pascal. This is probably the jankiest anything I've ever written, but it worked, and that's what matters. And surely we just picked an arbitrary section of RAM.
Yeah,
we thought, there's probably not anything important in here, which that's a safe decision to make. Sure, why not?
We got lucky.
Yeah. And as it turns out, we got lucky. We wrote some ASCII into memory. We dumped the RAM contents out of the emulator. And sure enough, when we went and looked at it, oh my God.
It was there.
It was there. We can now write debug information into memory. Then we have to go dump it and manually review the files. It's not like we're getting live output.
Yeah.
However, again, painful for that exact reason. So every every recompilation of all of this stuff that we're working on, we are having to completely reinstall the operating system we're working on. And we were on the phone for maybe like 4 or 5 hours.
Yeah.
Trying to most of that was spent waiting.
And I can take back over here because this is where like I put a bunch of stuff.
Yeah,
in.
yeah.
This
So
is all the
we eventually discovered we could just reiterate that procedure in Pascal to start putting debug output back in.
Yeah. And this is all the debug output that I ended up ultimately putting in. A whole lot of stuff just relating to loading segments. And it's a lot, but we'll go over some of the more important stuff here in a second. It's clear we're loading stuff into RAM because we're getting messages, right? Let's talk about what a segment is though, because it's kind of important. It's a relocatable chunk of code that in the Lisa's case can be a maximum of 32K in size. And well, the OS can of course swap it in and out of memory whenever it's needed. And by default, the OS will, or the the linker will put it into the blank segment unless you specify the code to go into any other segment. So the blank segment is just a segment that has no name. And generally, it's a good idea to put related code into the same segment to minimize having to swap things out to have two segments that depend on each other being in RAM at the same time. But that's basically what a segment is. And the job of the loader is to put all of, or not all, there are a few that don't get loaded that aren't resident, but it puts most of the OS's segments into RAM, just one after the other, then map them into the correct address space using the MMU, then hand control over to the OS. That is what the loader is supposed to do. And you can see here, some segments get loaded, right? We see done, now next seg, that means it's loaded. But the init CD segment, this one here, it does not. We call prog MMU, but then we never return from it. We never get it back from prog MMU. It never returns. So clearly, programming the MMU, we're getting stuck doing that. What's wrong? Well, this is where, since this is in the bootloader, we can just copy the original OS back over and we can compare what the original OS is doing compared to ours, and we can look for discrepancies. So let's do that. I looked through, and the noteworthy discrepancy that I found is this rel offset field right here. See how I'm printing that out here and here? Well, for the original OS, it's 260,000 hex, and for us, it's 60,000 hex. And this was a common pattern. There was always an extra 2 at the beginning it was always 200,000 hex larger for the real OS compared to our OS. So what's going on there? Well, let's look at find where it comes from. It ends up being the second long word of the segment header. If you're not familiar with like Motorola 68000 terminology, a long word is 32 bits. But yeah, you can see that here in the code. You can see what each thing in the segment header is. The first thing in the header is the type of the segment, then the segment number, then the size of the segment, and then finally we have the rel offset down here. But what does that mean? Let's first look at the headers. This is the header in our system.os, and this is the good system.os, the original. So there's the segment type. Then here is the size of the segment. Of course, they're going to be different, remember, because our segments are like sized slightly differently. And then there it is, 60,000 in the bad one, 260,000 in the good one. What's going on there? Well, let's look in one of the documents that describes the Lisa development system to see what the headers mean and see if we can figure out what rel offset is. Well, here it is, some random document on bit savers. And well, 85 means code block. That makes sense. This is indeed a code block, so at least that's good. Well, that rel offset though, it's an address, and it's the address of the first byte of code in the logical address space. See that right here. So the code is getting mapped into a different place in logical address space in the real OS versus our OS. And that seems a little weird for OS code. So let's look into this a little deeper. The rel offset is generated by the linker, not the compiler, because it's in the segment header, and the linker is what's generating that. So, well, let's look at the different linker options, and let's see what we got. Well, there's an option right here called F. And that will put things into domain 0, aka MMU context 0, which is like the privileged MMU context that the OS itself runs in. And well, by default, this is set to off. So let's try turning it on, because it makes sense for the OS to be loaded into MMU context 0, right? So let's try that. Guess what? Now the OS starts loading. Amazing. Look at that. Welcome to standalone version alpha of the OS, with tons of lovely debug info as well. But we got a problem. Error swapping in private code seg. So we're still having some issues. This took like 3 minutes to get to this point, so clearly a lot's happening. And after some further investigation, this was happening when it was loading segments of the environments window, which if you remember from earlier, that's the boot picker where you can choose whether you want to load into the workshop or the office system itself. So the OS seems to have fully loaded, and then it was in the process of loading the program that lets you boot into the shell. So the OS was done. It was just loading an application at this point, basically. So what caused it to break? What's going on here? That's really strange. Luckily, we have write line now, so we're not going to have to screw around with any of that nonsense anymore. No more write jank, thank God. So let's find that error swapping segment message and see what's going on. So it turns out it's in a procedure called code swap error. So let's find out what causes that. Of course, probably something related to code swapping. So here it is in a procedure called check code swap, and we can see here, it gets called right here, if some error code is greater than 0, or if this check byte is not equal to 85. Remember where we saw 85 before? That was the header type for a code block. So basically, if some error occurred or the thing we just put into memory isn't a code block, then we report a code swap error. So let's print out this error code and the check byte to see what they are. Let's see if one of them is wrong. Ignore all the other stuff I printed out. I'm kind of glossing over a bunch of false starts here. You know, this is the thing that actually mattered. Well, you can see the error code is fine, but the check byte, it's not. It is not right. So what does this mean? Well, it turns out that it means it's a packed code block instead of an unpacked code block. So what it was doing is it was loading, the OS was loading a packed code block into memory instead of unpacking it first and then loading it to memory. And of course, you can't directly execute a packed code block. So what the heck is causing that, though? It raises some serious questions. It raises some very serious questions, because why is system.shell packed? I compiled it myself, and I didn't pack anything. So why would it be packed? Well, it turns out it was my fault. I accidentally restored from a backup at one point that restored the original system.shell, and the original one was packed. But that doesn't explain everything, though, because it should automatically unpack it, though, given that we have that system unpack file that explains to the OS how it unpacks things. Well, the mystery for that is also user error. I definitely didn't delete that file a few days earlier because I thought we wouldn't need it anymore because I wasn't packing the OS. So this whole thing, this whole bunch of days, whole week of troubleshooting was entirely user error. Whoops. So we just either replace system.shell with my version or put system.unpack back, and look at that. It works. That's another problem fixed. So now when we boot into LOS, and we made it a lot further now, we can try to boot into the office system, but only get an illegal instruction error. So we got more problems. Oh, and by the way, if you're trying this in Lisa M, it's not going to work because the mouse scaling is screwed up. You're going to have to use my patched version of Lisa M in order to get it to work. I don't have time to explain right now, but maybe at the end, if I do, I can explain that. But yeah, illegal instruction error. What are we going to do about that? Well, I got really lucky and accidentally deleted system.print, which is the background printer process. And then it started kind of getting further. So I was able to figure out that the problem is clearly something in terms of loading system.print. What the heck? So I put some write lines in system.print to see what was going on there. And it failed in a different place every time. Non-deterministic error. How lovely. And so then I replaced system.print with a very simple program that just prints out numbers in an infinite loop, just 1, 2, 3, 4, 5, infinite loop, right? And it still failed in a different place. So even the simplest program in existence failed in a different place each time. What could be going on? Well, first, I was thinking, okay, maybe a segmentation problem. We have an extra driver segment that doesn't exist in the OS. I was just trying something random here, right? Just desperation, just trying some easy stuff first. So I tried mapping that to the blank segment instead. It didn't work. Then just some other random Hail Mary, just trying some random stuff. I tried changing the priority of the print process in the desktop manager where it launches it. I don't know why. I was just trying stuff. And that didn't do it either, of course. So then I started trying some actual serious troubleshooting instead of being lazy. So let's do a trace log, which basically just dumps all the instructions, all the 68K instructions that the processor is executing in Lisa M. And it's really helpful because you get a lot of instructions, and it also tells you sometimes, but not very consistently, the Pascal procedure names that are being executed during those instructions. But the files are huge. These are just gigantic text files that crash VS Code a lot of times because of how big they are. So, well, we search through them and we can find the illegal instruction error right where it happens because there's only one of those. And you can see that here. Illegal instruction error down here. And you'll notice the procedure that was being called here is called clock queue manager. But we were in system.print. Why are we calling this? This is not in system.print. And we're failing just a few instructions into this. So what the heck is going on here? Well, let's try and find out. Well, we're probably servicing an interrupt. That would make a lot of sense, right? So we search for clock queue manager. It turns out it's part of the OS, and it's part of an ISR that runs every 10 milliseconds. So that confirms that we are servicing an interrupt, right? But clearly it executes fine sometimes because at least it's been running for a lot more than 10 milliseconds, meaning that it has definitely run this quite a few times just fine. So let's try and find a run of this that actually worked earlier on in the trace log and see if there are any differences. There is. Look. This one worked fine, this one did not work fine. And there's a discrepancy that actually matters. The value of register A5, address register 5. This is the value when it worked, this is the value when it did not work. And it turns out this register very much matters because if you look at the good clock queue manager, what it's doing is down here, a few instructions in, it's doing a JSR to an offset from the data in A5. So if A5 is pointing to the wrong place, we got a very serious problem. And by the way, this points to a jump table. So then, so it jumps to the jump table, and then it jumps from the jump table to the routine that it needs to go to, right? But in ours, A5 is wrong. So it just jumps somewhere random in memory, executes garbage, and then a few instructions later, we get the illegal instruction as expected, right? So why is A5 being set wrong? Well, I basically just went back and traced tons of assembly language instructions trying to figure out where that could possibly be coming from. And it took a really long time, like days and days and days, because I went like way deep, way back. And it did tell me one interesting thing. And that is that whenever we're servicing an interrupt before clock queue manager that called a Pascal routine, it would set A5 properly. But if the ISR was written purely in assembly, then it would not set A5 properly and things would crash. But this doesn't make any sense because it's fine for an ISR, and generally better even because assembly is faster, for something to be written purely in assembly. So like this shouldn't be crashing things. So what's going on here? This is really odd. Well, I was able to find a routine called A5 setup that actually loads A5 for us. This is the routine that should be getting called and is getting called whenever a Pascal routine gets called from those other interrupts. So this is what's supposed to be getting called, but for some reason it's not in this particular case. And A5 is a pointer to the system global data area, which is pretty important in Pascal because that's how we get to the jump table and all that stuff. So that's very crucial. But what's going on? Let's do a trace log of the actual OS and compare and see if there are any differences. Well, there's a big difference. With the actual OS, that JSR is relative to the program counter. So A5 doesn't matter at all. With my OS, we're using A5. What's going on there? Remember the whole segmentation thing from earlier? That's about to come back. So, well, we're using the jump table, and the actual OS is just PC relative. So the reason for that is that if 2 bits of code are in the same segment, the Lisa OS will use PC relative addressing to get from one bit of code to the other. And in the original OS, that A5 setup procedure is in the same segment as the clock queue manager procedure. Whereas in our OS, they're not in the same segment, so we use the jump table and therefore A5 instead. But A5 isn't set properly, so we can't get to the routine to set A5 properly. So it's like a chicken and egg scenario. So the solution here, just put A5 setup and clock queue manager in the same segment. Let's try that. And let's also fix some other stuff. The segmentation of some other files was also a little bit screwed up. So I just went through, this is one of my build scripts, I just went through and tried to figure out what segments they were actually supposed to be in, fixed a lot of these. Those are the segment names. Fixed those, updated the exec script, rebuilt, bam, we're in, complete with all my lovely icons. And no, that says math, not meth. I just can't draw very well. But yeah, we are in. Look at that. But we're not done. We still need to fix Lisa right. Remember how that didn't work earlier? Remember how we hung? So, well, let's put some write lines in there. We know it failed when we pressed a key. So let's find out where we process key presses. And I'm going to have to gloss over some stuff here for the sake of time. Well, here's where we got stuck in an infinite loop and got that hourglass cursor. It turns out that this goto 5 here, it executes, and we get stuck in this infinite loop and just And it only executes, right, if f more to q is true. And, well, we need to figure out what sets the value of f more to q. Clearly, it's queuing up key events, and it's thinking that we have an infinite number of key events queuing up for some reason. Well, the answer is enqueue more here, this procedure here that we call, it is what is setting or clearing f more to q, depending on whether there's things in the queue or not. But guess what? Enqueue more is part of the spell checker, and we disable the entire spell checker. So, yeah, there is it's never being set to false. It can't change more to q. And it turns out literally everything that controls more to q is part of the spell checker. So it's not even getting initialized. It's just some random value which happens to be true. So it just gets initialized to true by default. We get set here. We get stuck there forever. It's supposed to be initialized to false in this initialization procedure for the spell checker, but we commented all that out. We patched out the spell checker, so that never gets run. So the solution here is in our initialization routines, we just manually set it to false. Problem solved, right? Now we can type. Ta-da! But we're not done. Now if we choose something from the find menu, it literally crashes the entire Lisa. What the heck? So we put more write lines around trying to figure out where it's crashing, and I eventually find some null pointers here. These should not be 0. These should not be 0. Also, what is this? This is utterly massive. Those numbers don't look right. And it turns out these are the pointers to the strings that are supposed to appear in the find dialog box. There's a string called find. You type in what you want to find and change to what you want to change it to. And these are the pointers to those strings, but they're null. That's really not good. So I searched through the source code to try and find where those strings are. They don't exist anywhere in the source code. What the heck? Where could they be? It turns out there is a special file on actual Lisa Write disks called t1 search.lotus. Lotus is the code name of Lisa Write, by the way, that I hadn't copied over to my disk because I didn't even know what it was for. I hadn't even noticed it, honestly. Guess what's in that file? These strings. That file wasn't there on our copy. So we were just getting null pointers because we were trying to open a file that didn't exist. So what if we copy that over? Ta-da! The dialog works, but now we get a bus error like a second or two after we open the dialog box. So we got another problem. Well, more write lines, and we got this little snippet here to blame. So if dbox is open is apparently true, so we execute this, and we call dbox track proc, and then we just get stuck there forever because of a null pointer, by the way. I'm not going to go into what that is, but null pointer issues inside of there. The weird thing here, though, is this isn't a checkbox. This is not a checkbox, but this code is only supposed to execute if it's a checkbox dialog box. What the heck is going on here? That's really weird. So let's look at what sets this to true or false. What sets that? Well, it turns out it's a function, not a variable, but the variable is the dbox.isOpen. So what sets that? Well, it's another spell checker thing. Inside the spell checker is the only thing that uses checkboxes, and that is initialized to false inside the spell checker initialization, but we deleted all that. So it's undefined, defaulting to true. So we add underneath our patch for f more to q, we add one for the dbox.isOpen, and look at this. Now we can find completely and replace it with fully, and Lisa Write is now fully functional. Let's also add this. Since none of the spell checker options in the spelling menu work, let's just add a little alert that pops up when you try and use it. So we go into the phrase file for Lisa Write. We add an alert. This is the alert ID. And this is the type of alert. It's a note alert, which you'll see what that means in a second. And hey, the spell checker doesn't work. You can change it whatever you want. We can say some really silly stuff. And then this is the code that executes when you choose something from that menu. So we just call the alert manager in here. We tell it to put up a note alert. This is the alert file. That's the alert ID. So we just say put up that alert as a note alert. And bam. Now we choose something from the spelling menu and it says note, the spell checker doesn't work. Ta-da! Look at that. Cool little patch. And look at my icon. That looks really good. That looks just like the original Lisa Write icon. I'm pretty proud of that one. Final task, the LOS installer. This one, it was basically just one file, apin/office.txt. This is just the installer that pops up when you boot from the LOS install disk. And it's got a phrase file too. It all compiled and linked just fine. And you name it system.shell because there's no environments window on the install disk. So you just name this the equivalent of the environments window, right? Because it's what you want the OS to load. So we do that, we copy it to an install disk, reboot, and bam, it works. The issue, though, is that the install disk uses a custom library file that's not the regular sys1 lib, sys2 lib, because they're too big to fit on a 400K floppy. So we have to make our own that's smaller. And we also need iOS paslib because Pascal stuff. So we have to create a custom intrinsic library directory that's smaller with just those files included. And fortunately, Apple gave us scripts for most of this, so it's actually not as hard as you might think it is. But there is a major issue here. And that is that look how big ours is compared to theirs. You know why? PackSeg. And this is an issue where we actually can't do anything about it because we don't have PackSeg. So we just can't fit this onto the disk. We can't completely make our own new installer, but at least we can make the installer app, and I guess that's good enough. But we can't actually copy the install library, sadly. Finally, I got Lisa Guide, which is the Lisa tutorial thing working, but it won't fit on a 400K disk either because it's PackSeg. So didn't really want to even bother talking about that because it's kind of boring. And this. So limitations, well, we just talked about that. We're missing some source files, so we can't make those two libraries or Lisa Write Dictionary, but none of those are a huge deal in my opinion. Also, we can't build anything that uses the older library versions, but none of those are super important. They don't really matter. They're just some cool little programs. Some discoveries. This is, don't worry, we are like actually at the end. This is pretty interesting. You can actually enable debug flags for pretty much every app, and there are tons of write line statements throughout like every application. So you can see tons of cool debug info fly by. It makes them super slow though, but you can see tons of cool info. Some of the graphical apps even have extra hidden debug menus that'll pop up on the menu bar, so you can choose cool debugging options and stuff. But this is a big one, big misconception. A lot of people have said that there are a lot of write lines that are just enabled by default throughout the entire Office system code base, and that's why the OS is so slow. That is just false. They are all compiled out by default. That is just blatantly false. In fact, if you have just the ones in the OS, not even including the libraries, enabled, it takes the OS from a 1-minute boot to a 45-minute boot. So that is just false. Improvements. We already did this, expanded profile capacity. We're planning on modifying the OS so that it'll work with this Macintosh screen mod that changes the dimensions of the screen to make it better for Mac OS. So that'll be pretty cool. Why 1.995K compliant, so the Lisa's clock will work for years after 1995. I'm working on this right now, actually. There's a bug, though. It reports like years as like 2068 for some reason. So making progress, but it's not working yet. Removing the serial number check, so there's no more Lisa DRM. That shouldn't be very hard. And maybe SCSI drivers or something cool like that for the Lisa OS. And then Will has one final thing to say about a cool project he's been working on involving Pascal that will be ported to the Lisa at some point.
Okay. And I guess just a quick thing. So the why 1995K issue is caused by the microcontroller on the I/O card where it has NV RAM in it, where it actually keeps the date. The year is encoded as a 4-bit number.
Yeah.
So you can only
1980 to 1995.
Yeah, you can only count to 16.
Yeah.
Yeah.
Oh, hold on. Sorry. One thing I completely forgot. This.
Oh, yes.
I don't know how I forgot. This is what happens if you compile the entire OS from start to finish, but redirect all the compiler, linker, everything output to the printer. And
You get a boat anchor.
603 pages. God. Also, 9 hours from start to finish building the entire everything we just talked about.
Okay, so this wouldn't be a presentation about Apple without one more thing. So while Alex was working on the lion's share of figuring out what made LOS tick, I had been working on learning as much about Pascal as I could to help out wherever I could. Y'all saw right, Jank. I don't have to explain too much. So what I was working on in the background, and it was pretty much free time at night after my wife and I put our 2-year-old to bed, so like an hour here and there, maybe over 6 months, is a project called Prism. And as far as I'm aware, this is the first game for the Lisa Office system at the end of the day.
I think so. I can't think of anything else.
Yeah, I haven't been able to find anything
Unless you
else.
count Lisa balls. That's not really a game, but like,
yeah, not really.
Yeah.
But so I assume most are probably familiar with Infocom and the text adventures that they produced. Prism is a Z machine interpreter for those story files. It is in progress. It is going to be compatible with everything except V6, which were the graphical games that they made. Those were all intended to be run in color. Obviously, the Lisa's monochromatic, not much of a reason to do that. Also, the stuff you have to implement for those games is way more complicated, so I really didn't want to do them. It's pre-alpha at the moment. It's about 80% done. It's being written in Free Pascal in Linux, and we're at the point where I have tried to maintain as strict a compatibility with UCSD Pascal, which is sort of the immediate precursor to the Lisa's Pascal. It runs a variant of UCSD Pascal with some minor changes to it. That is going to allow us to hopefully, again, easy is a word that comes with strings attached, easily backport that into the workshop and have that run as a text-only application. And then once that is successfully running in the workshop, working to port that using the toolkit libraries as an actual graphical application on the desktop with a menu system that you can thumb through to interact with, load files, save files, turn on debug info. I don't know if anybody's really dived into how the Z machine works. I'd really like to give a talk about that next year. It's a real fascinating piece of software that Infocom developed. It's entirely open source. That link is private at the moment. Once it reaches alpha, hopefully by the end of summer, where everything is functional and we're really not running into any more serious bugs, that will be available for you to just go at and browse through the Pascal source. It's not very pretty at the moment, but it works. It needs to be refactored eventually, and then it will get taken back down into proper classical, which is technically the language of the Pascal variant that the Lisa speaks. So coming soon, hopefully by the time VCF 26 rolls around, this is a thing that you'll actually be able to go download in a compiled form as a disk image, throw it in your Lisa or Lisa M, and play. So that is coming soon. So, and that's it.
I know we kind of went over time a little bit, but does anybody have any, if we still have the room, does anybody have
I
any
have about
questions?
10 minutes. So yeah, if anybody's got questions.
With all the knowledge and experience you guys now have, do you think some of those, beta, alpha features of networking and stuff would be in your capabilities to implement, or?
So networking, there's like just so little there right now. I mean, Apple already designed AppleNet cards for the Lisa, and they're like a few of the, not very many, but they're like a few of those out there. So we would have to write a driver for that, and then it would be complicated, doable, but it would be quite complicated.
I'm sorry?
Can you work with the FujiNet guy?
That would actually probably be really cool.
That would probably be the best way to do it. Yeah,
because there's not even TCP/IP stack.
No.
I mean, this predates TCP/IP, I think, by a little bit.
For context of how far they got with the networking code, they added about, I think, 8 lines of code maybe, and that's about all.
The heck with this, we got a Macintosh to make.
Enough to show the icons and somehow corrupt the file system, and that's all they added.
Yeah.
They didn't get far.
So quick question, are there any plans to implement the sec pack so you can get that working, or are you just kind of not even going to look into that?
I think we'd like to.
We'd like to, yeah. I got some other things I need to work on first, especially involving some computers I picked up here that I need to fix. But eventually, yes, that would be really cool.
So are you just going to reverse? You just have to reverse engineer the existing one basically, and decompile it and re-implement it or something. Is that how that would work? Or?
Probably. Yeah, we'll have to figure it all out once we get there, but probably so. Yeah. Yeah. Yeah.
You never introduced yourselves. Who are you?
Oh yeah, you're right.
Yeah.
Okay, so I'm Alex Anderson-McLeod. I'm from Columbia, South Carolina, and I can't really say I'm a PhD student because I'm just starting, but
He's a PhD student.
I'm a PhD student at the University of South Carolina in computer engineering, and I have a slight obsession with the Lisa, and I've designed a bunch of stuff for it, like the ES Profile hard drive emulator. If you've used one of those, that's my design. I've designed a bunch of boards for it. I have a big obsession with it, and that's about all to say about me, really.
I'm Will Tooker. I'm from the Fort Worth area. I am not a PhD student, sadly. I'm by day a systems architect. I do infrastructure for a natural gas company, and that has allowed me a tremendous learning experience over the last several years. By night, I do this stuff, and I have a 2-year-old now, so this stuff is having to be compressed into very, very little time. But yeah, no, I've been working with Alex on reverse engineering a lot of the Lisa hardware over the last few years. Basically, at this point, between the two of us, I think there's a complete board set that you can basically
People
manufacture.
have made like brand new Lisas from our.
Yes,
You
yeah,
can make a brand new Lisa at this point. In
Yeah,
time,
the first one of these that we were at, we just sort of unveiled, oh, hey, we've managed to reproduce all the stuff. If you want to go build your own Lisa, you can. And I think like 2 people at that point had, and now
No, it's more than 2. I don't know how many exactly.
way,
It's a
way
good number,
more than 2. So that's us.
Yep.
Yeah.
So, with the introductory slide that you guys had, where you said that you're using the real hardware as much as possible, just to confirm, like, you guys are doing code compilation on the Lisa?
Yes.
Yes.
Okay, I have to ask, so like, what is the average time? If I have no point of reference, you
Oh, God.
for something like Lisa, right? And also, if you had to like guess, what is the total amount of time that you spend just waiting for code compilation?
Okay, total amount of time spent waiting for code compilation, I would put on the order of probably like 1,000 hours in total, roughly.
Yeah.
This took a long time. This took a very long time.
This is we had a few phone calls where just Zoom meetings where we were
Sitting
he
there,
was
yeah.
screen sharing with his OBS setup, so I was watching everything was going.
Yeah.
These calls would be like 3 to 6 hours, and 90% of that would be just watching text fly up a screen.
Yeah.
And then on a single, like, so like on a single code compile, something like Lisa, right, like how long is that?
So Lisa Wright, I believe, was one of the longer apps. I think it would take about 35, 45 minutes, something like that. The calculator, for instance, it would take about maybe like 7 minutes or so. The OS takes about 45 minutes. All the apps all together take about 3.5 hours. Yeah, those are just some. I have a whole text document with like a lot of the times written out, but those are the ones I remember off the top of my head.
Does it make you say, I want to use the emulator because it's faster?
Okay, Lisa M is also like really buggy too.
Yes.
So like there are trade-offs. The emulator is a lot. You can run the emulator at 512 megahertz, so that makes things fly. But it just feels like cheating to do that. So I only turn to the emulator when I absolutely had to dump the RAM for that OS part. Everything else was actually, and I have footage to prove it. I'm hoping to make a YouTube series of how I did this entire thing. So I have footage to prove it, that it was done on actual hardware.
Instead of, are you using your accelerator though to do that?
So the accelerator doesn't actually even work in the Office system. It only works in MacWorks, in Mac OS. So you can't even.
Import that back into the Office system.
Possibly. That would be quite a challenge, but possibly. That is something that's probably be up to James will be the most qualified person to do that.
Yes.
But I don't know if he would do that or not.
There is actually one tiny, tiny little technical snare that you run into when you try to use the accelerator with anything but MacWorks, and it's that when the Lisa is booting up, one of the very first things it does is it looks inside of a tiny little PROM that is effectively a state machine. It has no usable info in it except for one thing, and that's a serial number. And if you have an accelerator active in your Lisa and you try to boot into LOS, it makes the Lisa go too fast for the PROM's actual electrical function to spit the serial number back out. So it thinks you're just running pirated software and gives up.
Yeah. And that's not even with the accelerator on. The accelerator's not even turned on. It's just like slightly faster instruction cache timings or something that like do that. It's very time sensitive. They made it that way on purpose so that you can't just like.
You couldn't do what we're doing.
Yeah. But no accelerator, no cheating. Stock Lisa only upgrade was hard drive, my hard drive emulator, of course, because we need more space, and 2 megs of RAM. But that was something you could get at the time.
Yeah.
And I'm using original hardware for that too. So like,
And
that was. Yeah, that's the point. I just haven't gotten around to it yet because like it was hard enough to get everything ready in time for VCF. So haven't gotten around to like doing a lot of patches or anything yet. But yes, you could totally just patch out the check, and that is the ultimate plan. But that still doesn't turn on the accelerator. The accelerator has to be turned on.
Yeah.
And we're not completely sure how to do that because like the software to do all that is like MacWorks only, and I'm not sure that
That's
James
still
would release any of those
incredibly
details.
proprietary.
So, very
Yeah.
proprietary. So
Yeah.
You know, for the disk space issue that you were facing whenever you were doing all this, do you know if Apple themselves had some kind of other dev kit that would have?
the data tower.
So they were probably developing this on a data tower because that was really the only thing. So it should be said, later development would have been done on a Lisa using probably a data tower. That's literally just the only thing, unless they had some hacked together profile interface using a custom hard disk. Because again, the logic in that if statement was if it's less than 10,000 blocks or more than 30,000, which implies that maybe there was a 15 meg profile at some point that they were working. There's no documents that hint towards that, but yeah, they would have used a data tower probably. Earlier development was actually done in UCSD Pascal on Apple IIs and Apple IIIs.
And then bootstrapped over. But that was very early.
Very early.
The moment they got like a
late 70s, 1980 maybe
Yeah.
was when they were doing that.
the moment they had like a very base working system on the Lisa, they used the Lisa for everything.
Yeah.
And I will say you can actually have the code span multiple disks. That is very much a thing.
Yes.
The only issue with that though is it just makes everything much more confusing. And if you want to reference a file on one disk from another, you gotta,
Yeah, you have to make
change the paths
significant
and everything.
code changes to reflect
You
that.
can do that. It's just why would you want to?
Yeah.
Just get a bigger.
Yeah,
code.
so sorry, that was a bit of a misstatement. I do apologize. Yeah.
Are there any of the original Lisa developers still around? I mean, have you tried contacting them to help with some of these mysteries?
There definitely are. I just don't.
There are.
haven't
I don't even know
contacted
how.
any of them.
I don't know how you'd get a hold of any or many of them because a lot of those guys are retired because they're in their 80s now, and a couple of them have actually passed.
Like Bill Atkinson.
Bill
for
Atkinson passed. I think Larry Tesler passed a few years ago.
I think you might have.
Yeah, the really, really prominent folks are, some of them have passed or they're way up there in years, and I doubt they're not going to be on LinkedIn. So,
Also, I'm sure-
unfortunately.
Also, I'm sure a lot of them might not want to be bothered. Like, God, why does everybody keep annoying me with all this stuff?
You're calling me about what?
Yeah.
Who gave you this number?
Yeah, I mean, it's maybe worth it. I didn't even really consider that.
Well, and I think
but-
at this point, since we have a finished product, maybe it would be worth reaching out.
Yeah, just reaching out. Hey, look what we did. You might be interested.
Of course, Apple might send lawyers to our doors at some point. I don't know.
True.
So,
They lost their most recent lawsuit though against Epic. So like,
you never know.
They're gonna say, look, maybe you're 4 bits for a reason.
Yes.
Speaking of like Apple sending lawyers to nuke you from orbit, I'm curious, like, is that the reason why you guys redrew the icons? Is it to not run afoul of like the
Oh.
that was just for fun because I wanted to. That was just because I wanted to see like if I could do any decent job, and then it just kind of became a joke because I was like, okay, these are just like so bad they're good, and then they actually started becoming kind of good.
Now,
yeah.
I will say this real quick, and that is, a couple of years ago, I very briefly touched on this. The licensing terms under which Apple released the source code is very, we'll call it cantankerous. They released it under a brand new type of license, what they refer to as the Apple Educational License. And what it basically entitles you to is you individually to possess a copy of the source code to modify at your discretion and compile, if you can, and then it's yours to do with. However, you are not allowed to distribute any of your compiled code. You are not allowed to share your changes in mass. So you can't just re-upload the software or all of the code to GitHub with your changes. What you are allowed to do is document your changes and share your documentation with anyone you would like to share it with.
And that's what I am going to do. If you check the Lisa List 2 forums over, I don't know, maybe like next week or two, I will be putting all the build scripts up there, and I'll be documenting, as I might forget some because there were so many changes, but I'll be documenting as many of the changes to the source files as I can remember up there so that people can recreate this. I wish I could just share a disk image, but I can't do that because Apple won't allow me.
Yeah.
Boo!
So I didn't see that you ran into problems with quick draw, so why didn't you have rounded rectangles on your rebuild apps?
On
like on the calculator?
Yeah, so most of the apps don't use rounded rectangles. The calculator and clock do. I'm not, yeah, I never figured out, I kind of just ignored that. I am not sure why the calculator and clock were rounded on the originals, but not on mine. I'm guessing it's something with the install tool. You can specify a stationary opening window in the install tool. That window though is rectangular though, so I'm guessing maybe Apple has some like special way of like modifying something in the catalog file that told it to open with round recs. I'm not 100% sure about that. But
Yeah, I would imagine that.
I just kind of ignored it. I was like, it's good enough.
Right angles, I would imagine, is the default if
It
it's
100%
undefined,
is,
so, yeah.
but they clearly did it somehow. I just don't know how off the top of my head. But yeah, good catch. I wasn't sure if anyone would catch that, but yeah.
Would you be able to make something where you can basically put something available so people could download it, press one button, and then they can compile it themselves without a lot of programmatic knowledge themselves?
No.
Yeah, probably
Probably not.
'Cause that
It
would
would
still
be-
involve distributing the changes. I don't know. That would be kind of some gray area.
And I think we're still trying to figure out to what extent plain text changes can be directly shared.
Yeah.
Because what constitutes a change versus what constitutes new code that we've written that's entirely divorced from the legal entity that is the original source code is somewhat ambiguous in the license. They probably left it that way for a reason. I am not a lawyer. Your mileage may vary.
Yeah.
You know how that goes, unfortunately. So.
Yeah.
I saw a couple of other hands at some point that I apologize. Other people got called on. Did anybody else have anything?
No, we're good. Everybody?
You good?
Yeah.
All right. Thank y'all.